What's good, everybody? Today, we're gonna be learning about how to write and name ionic compounds. But first, we're just gonna talk about some of the trends in the type of charge or the oxidation state that these elements will go through. So, starting with group 1, these elements, besides hydrogen, they like to tend they tend to form a +1 ion. And group 2, these elements tend to form a +2 ion. Now why? Because the first group, they have one valence electron, and because they want to reach the noble gas configuration, it's easier for them to just lose that one electron and form a positive cation. So these metals, they want to form cations. And group 2, because now they have two valence electrons, the group 2 elements, they'll lose their two electrons. So they'll form a +2 cation. And now let's look at the elements to the right. So let's look at the halogens. So fluorine, chlorine, all of that. Oh, these elements, they have 7 valence electrons. So they're going to form a -1 charge. They're going to have a -1 oxidation state because they're only one electron away from getting the full valence shell. So they want to gain one electron, thus forming a anion. Now, what about the group next to it, to the left? So we have oxygen, sulfur, selenium. What about that group? Group 16. Well, because these elements, they have 6 valence electrons now, they want to gain 2 electrons to get to their noble gas configuration. So they're going to form a -2 anion because they're only 2 away. So elements to the left, they want to lose their electrons. And you can see how elements to the right, they want to gain electrons. And elements in the same group, it's excluding transition metals, they usually have the same oxidation state. Now, that was kind of the introduction. Now we're gonna start naming ionic compounds. So first, we got NaCl. So this is commonly known as table salt. And how we name it, ionic compounds are actually pretty easy to name. So first, you have to take the first element, the metal element, which is Na. And that's sodium. So sodium, and then the other element, Cl. Cl is chlorine. But when you're naming the non-metal, you have to put the suffix IDE. So chlorine becomes chloride. And if you put that together, you get sodium, which is the first element, and then chloride, which is the second element. Now let's do the second one. First, we get our metal, so that's lithium. And then once again, we have chloride, lithium chloride. The chlorine turns into a chloride. Now, next one. You could pause the video and try to find out how to name the next two ionic compounds. Well, let's take a look at the third one. So once again, we have our metal, which is sodium. And then we have our non-metal, phosphorus. But remember that the non-metal is going to get the suffix IDE. So it's going to be sodium phosphide. So instead of phosphorus, you get the IDE. Now let's move on to the last one. So we got magnesium as our metal. So we get magnesium and then sulfur. But then sulfur gets the suffix IDE. So sulfur becomes sulfide. So we get magnesium sulfide. Now we're going to try to write some ionic compounds. So first we got sodium oxide. Now we're going to do a simple method called the crisscross method. So we have sodium, which is Na. That's our first element. And then we have oxygen, because we know that oxygen turns into oxide when we name it. So sodium is a metal, and then oxygen is the non-metal. And then what the crisscross method does is it takes the charges of the ion. So this is where you take out your periodic table and you look at the number on the top right of the element. So in Na, this has a oxidation state of +1. In oxygen, this has an oxidation state of -2. And you take the charges of the ion and you swap them as subscripts. So what I mean by that is the -2 from the oxygen, it goes down to become the subscript of sodium. So there's going to be two sodiums. And in sodium, this has a +1 charge. So it goes down to be the oxygen's subscript. So there's only going to be one oxygen. And then your final product is going to be Na2, because you get the 2 from the oxygen's oxidation number, and then just oxygen, because the 1, well, the single oxygen, that kind of implies that there's a 1. So sodium, there's a 2, and then oxygen. When you're writing these ionic compounds, you always have to make sure that the charges add up to 0. So what I mean by that is there's two sodiums, right, with a +1 charge. And then there's one oxygen with a -2 charge. So if you add up 2 plus -2, you have to get 0. So you have to make sure that the positive charge and the negative charge adds up to 0. Now let's do another example. So in calcium fluoride. Well, calcium, this is element 55, CS, and it has a charge of +1. Fluoride, well, this is just fluorine, and fluorine has a charge of -1. So we have CS +1, F -1. And using the same method we did before, we're just going to get CS, F. Now, one important thing to know is that when the charges of the ions in the compound, they're numerically equal, but they're opposite in sign. So let's say we have one element with a charge of +3 and another element with a charge of -3. You only need to write one of each element, because the signs, you could see how the +3 and the -3, they balance each other out. So because in an ionic compound, your charges, your negative charge and your positive charge, have to balance each other out. If they're numerically equal, but they're opposite in the sign, then it makes sense that you only need one of each element to balance each other out. Now we got beryllium carbide. So beryllium, element 4, is just Be, and it has a charge of +2. And now we have carbon, and this has a charge of -4. So using the crisscross method, there's 4 Be's and 2 carbons. So you get Be4 and then C2. But there's one thing you gotta know when using the crisscross method. If the two elements still have a common factor, you have to reduce. So because 4 and 2 they share a common factor of 2, you have to reduce this. So you have to get Be2 and then 1 carbon. So you see how you reduce the 4 and the 2 to a 2 and a 1? And this is really important. And that's it, guys. In the future, I'll probably make a video on how to write a formula for an ionic compound with a transition metal, and also how to name ionic compounds with a transition metals, as well as doing the same for polyatomic ions. And yeah, have a nice day, guys.